Assalamu alaikum wa rahmatullah. Good day, students. And in this video, we will explain how we can use the observations we obtain from a physics practical to plot graphs and do more evaluations from the observation. Here with me are the results for experiment outlined in chapter 5 according to our practical manual. Now, we have the first column for the length of a simple pendulum. We varied the length from 10 or 100 centimeters all the way down to 30 centimeters. Then for every single length, we time for 20 oscillations twice, T1, T2. We got this, and then we got the average of T1 and T2. This is T average. This plus this, whatever you got divided by 2 will give you this. Then the next column, this is the period of oscillations. We are dividing what we got here by 20 because they say for 20 oscillations, and period is the time taken to make one complete oscillations. Since this time is for 20 oscillations, we divide it by 20 to get the time taken to make one complete oscillations, and that time is our period denoted by capital T, and you can see in the bracket it is defined as T average divided by 20. So we take this divided by 20 using our calculator, we will get 2.03. Finally, we square this, t squared, meaning the period that we got in this column, we have to square it to obtain this. So this is in a nutshell how we got the table completed. Now let me bring the manual and see what we are supposed to do according to chapter 5. Here are the questions in chapter 5, section 5.8. You have questions here. Roman number 1 in the question says, plot a graph of t squared on the vertical axis, meaning this column, the last column you got here, should be on the vertical axis. Then what? Against L on the horizontal axis, and L is the first column. So at the end of the day, only the first column and the last column are relevant. We will use them to plot the graph. So that's the very first question. Plot a graph of t squared on the vertical axis against L on the horizontal axis. Now let's see how we can plot the graph. Okay, I'm going to use this graph sheet provided by the university. Here you see, I have the university logo. Okay, now the vertical axis, I'm going to draw the vertical axis now. Okay, make sure you use this ruler, this long transparent ruler is the best option. Don't use small ones. So I'm going to draw my and I'm using black pen here, well, pen with black ink here, so that you can see clearly, but you have to use a pencil. Okay, the purpose of doing this is for you to see it clearly. Okay, the big lines, the thick lines, okay, these thick lines that you see, vertical and horizontal, we call them secondary grid, and then the small ones are primary grid. So you are using the secondary grid, one vertical, one horizontal, for the axis. So I'm using here, let me see, okay, place my meter rule here. Okay, so this is my ruler. Now I will draw this. Great. So I have to put arrow here, and I call this t squared, and its unit is second squared. So this is my t squared axis. Then I will go down. See. Okay. Great. So I will now draw the horizontal one. I'm drawing the horizontal. Oh, sorry. I will draw the horizontal one. Then, so here, well, because they say against L on the horizontal axis, so this is my L in centimeters. You see, I have L in centimeters on the horizontal. On the vertical, I have T squared in second. This is the origin for both. Everything here is 0. 0 for this one, on the horizontal, and on the vertical, this is also 0 at this point. Now, the next thing is scaling. I have to take scale. Uh, from one secondary grade to the next, we have 10 equal divisions. Okay, we have 10 divisions. If you count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now from here to here is arbitrarily taken to be 2 centimeters. Okay, 2 centimeters. If you count from here to here again, you will see that it's 10. You see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's also another 2 centimeters. So we are taking our scale based on that. On the vertical axis, what you have is t squared. So you look at the values that you have. You see, the highest you have is 4.1. It's not even up to 5. So if you take 2 centimeters, where is it from here on the vertical? If you take 2 centimeters, meaning from here to here, you can see him. So okay, now meaning from here to here, if you take 2 centimeters from here to here as 1, then you have from here to here 1, then the next one will be 2, the next one will be 3, the next one will be 4. And you can see that the length is very small, so you have the point somewhere here. They will not exceed this point. This is not desirable. Okay, we want it to be large. We need a big space here if we have that opportunity. And clearly, according to what we have here, we have the opportunity to do better. So instead of making it 1, we can say 2 centimeters represent 0.5. So that from here to here we have 0.5, then another 0.5 make 1, another 0.5 make 1.5. If we can get up to 5, at least 1 point, at least 1 beyond this 4. Okay, where is it? Okay, so now this should be 0.50, and then another the next one should be 1.00, then this one should be 1.50, and then the next one 2.00, then 2.50. You are adding 0.5 to the preceding one. Now this one 3.00, and then the next one 3.5, sorry, 3.50, then 4.00, then I have 4.50, and finally here this is 5.00. You see, so we have enlarged the scale. Now we have to write this somewhere here. Let's say scale, and then we put full column. We are going to say on t squared second squared axis, that is the vertical axis, comma, 2 centimeters represent, okay, this means it's equivalent to, so it represents 0.50 units on that. So as you can see, from 0 here to here, this is 2 centimeters, so you have 0.50, so you write it here. 2 centimeters represent 0.5 0 unit. But in the graph, let's see, let me show you that. You are given a graph, you are given a graph sheet here, okay, for mashallah. So here, this is where you write it, y-axis scale, okay. You just write here 2 centimeters represent 0.50 unit here. That's that. Okay. Then the next one we go to, on what do you have on the horizontal axis? L. So on L in centimeter axis, that is the x-axis, 2 centimeters, okay, represent what? We have to look at the values we have here on the vertical axis. You see, from 30 all the way to 100. The highest we have is 100. So now we can't say 1 centimeter represents 0.5 or even 1, because it won't be up to that. Let's try 10 and see. If we say from here to here 2 centimeter represent 10 units, then it will be 10, 20, 30, 40, 50, 60, 70. No, it's not even up to 100. So we are going to try 20. Okay, 20 from 2 centimeters represent 20. So 20, 40, 60, 80, you see, 100. So 20 is better. So we're going to put 20.0 here, and then here 40.0. Okay, then here 60.0, 80.0, 100.0, 120.0. See, now 2 centimeters represent 20 units. We have to write it here. 2 centimeters represent 20 units. You see, this one is not up to 1, so I did not write S here. It should be singular, but this is more than 1. It's 20, so I had to write S to indicate plural. Okay. The next thing I'm going to do is plotting the point. Let me bring this on the, when I have 100, when my L is 100 centimeters, my T square, okay, is 4.12. How do I get 4.12? You see the 100, I can easily see it here. This is my 100 centimeters. But how do I get this 4.12? Let me show you that. We know that from here to here is 0.50, and we have 10 equal divisions. So to get the measurement for every small division, we have to divide this by 10. We take 0.50 and divide it by 10. It will give us 0.05. So this means this is 0.05, and then if you add another 0.05, it will be 0.1, meaning every two small divisions will give you 0.1. Let's see, 0.05, then 0.1, 152, 253, 354, 45, and then you have 0.5. Then 55, 6, 657, 758, 859, 95, then 1, and on and on. So this means every small division, okay, on the vertical axis, every the distance between a primary grid and the next primary grid is 0.05, okay, and every two will give you 0.10. Okay, so if I want to get 4, what I want to get here is 4.12. You can see that I can't get 4.12 exactly, okay, but I can get 4.1 something. Let's go to 4. This is 4, okay. two small divisions beyond 4, this will be 4.1. But if I go here, this should be 4.5, 4.15, which is more than what I need. What I need is 4.12. So I will go beyond this point, but not up to this point. Okay. So where is my 100? This is my 100. So my 100 is here, so I'm going to trace this. I'm going to follow this vertical grid until I reach this 4. So this is where, this is my line from 100. So you can see this is 4 and this is 4.1. If I go up there, it's 4.15 and it's not up to 4.1. So I'll just go a little beyond this point. Okay, so this is the point I want. Okay, next is when I have 80, I have 4.24, but I can't have 4.24. I can only have 4.25. Okay, so where is my is it 4.24? Let me see, 3.24. Wow, 3.24. So this is 80 and then this is 3.24. Wow, so this is my 80. You see, so I will now follow this line, my 80. Then this is my 3. Okay, this is the line from 80. So this is the line from 80. This is my 3. So I will now say 3.1. You see, after these two small divisions will be 3.1, then 3.2, and the next one will be 3.25. I can't have 24 exactly. Okay, so I will just take this one. This is the closest I can get. Now I have this point. Okay, next is when I have 60, it is 2.46. Again, I can't have 2.46 exactly, but I can have 2.45. Remember that we cannot put all the 4 decimal places in the graph. We can only do it as far as 2 decimal places. We can't go beyond 2 decimal places. This is why we are doing this. Okay, but computers can do that. Okay, 60. So where is my 60? Great, this is 60. So I go up and then where is 260 and here is 2. Okay, so but they say 2.46, so this is 2.1. You see, 2. Okay, 2.1, 2.2, 2.3, 2.4, 2.5. You see, so this is 2.4 and this is 2.545 here. That's the furthest I can get. I can't have 2.45 exactly, but I can't have 2.46 exactly. I can only have 2.45. So this is my point here. Okay, next, the next one is when I have 50, it is 2.04. Again, I cannot have 2.04 exactly, but I can have 2.05. Okay, you have to do approximations while plotting the graph as well. So 50, where is my 50? Okay, my 50 is between 40 and 50. Okay, since this from here to here I have 10 equal divisions, I will just count 5. I will simply count 5. So 1, 2, 3, 4, 5. This is where my 50 is. So but when it is 50, I have 2.04. Okay, I can only have 2.05. So Let's go up here. Where is 2? This is my 2. So let me see. 1, 2, 3, 4, 5. So this is where my 50 is. And the next one is 2.05 because this is 2.1. So I can only have 2.05. So this should be my point. Next, the next one, which is the last one, is we have 30 here. 30 and then 1.21. I can't have 1.21. I can only have 1.20. Okay, 1.20. So where is 30? Again, 30 is between 20 and 40. 1, 2, 3, 4, 5. This is 30. Then 1.2, this is where I have 1. So this is my line from 30. Or let's see, this is 1, 1.1, 1, how many division? 1, 2, 1.1, 1 to 1.2. Then 30, this one is, okay, this is 40, so I have to go back. You can see this is 40. And what I need is 30, so I will count 5 backward. 1, 2, 3, 4, 5. This is my point. Okay, 1, 2, 3, 4, 5. Yeah, great. So you can see that I have all the points I need, all of them. Let me change it to 1. Great. See, I have all my points, all the 5. 1, 2, 3, 4, 5. Now I have to draw a line, okay, we call it line of best fit, to join them. Remember, according to the theory, it has to pass through the origin. It has to pass through the origin. So if you adjust this, it's not necessary that all of them should the line should pass through all of them, okay, but they should be close to the line as possible. Okay, great. You see, I can draw a line. You see, my line will pass through the origin. So let me see. This is my line of best fit. See, this is my line of best fit. Okay, after drawing this line, the next thing you need to do is to take any 2 points. The point should be far away from each other, and then you make a triangle out of that. How do I choose the points? Let me show you. If I have a vertical grid and I have a horizontal grid, then the line, my graph, passes through their point of intersection. Let me repeat that. This is a vertical grid. This is a horizontal grid. This point is the point where the 2 lines meet. Now, if my graph passes through this point of intersection, I'm going to take this point. So let me zoom it, and then we check that together. Okay. Okay, let's see that. Okay, let's check that. Let's start from here beyond this, and wow, can you see this? This point is great. Where this one, I have a vertical grid here. You see, let me bring it close. Yeah, this point, I love this point. See another one here. Wow, this is even better. You see, you have a vertical grid here, you have a horizontal grid here, and then your line passes through their point of intersection. So I'm going to take this point. It's interesting. So let me take this point. Okay, now I have to go far above and see if I can get another point beyond this last point. You see, this one is also great, but let's go further and see. Wow, this one is also great. Let's see if we can get anyone. This one is great. See, And this one, wow, I love this one, but it's a bit above here. You see, it's above my scale, so I can't take this. So let me see. uh Wow, let's take this. Okay. Now, after that, what you should do now is to draw the triangle. See? You have to draw a triangle. You follow the vertical grid. Okay. Draw a line here. Oh, let's adjust that. Yeah. Okay. Let's see. Great. Great. So now this is the triangle we need. Now we are going to use this triangle to evaluate the slope. You can see this one, the value that you have here is important. We are going to call it L1, and then its corresponding value on the vertical axis, we will call it T square 1. Next, this one, what you have here. Okay, now let's go up here and see the value we have here. Let's trace the primary grid here. Okay, what we have here is our T squared 2. Okay, we will use this to get our slope. Okay, let's go back to the manual. The manual says the second thing we should do is to determine the slope S of the graph. Determine the slope S of the graph. Okay. Now we are going to use the triangle to determine the slope. On the horizontal axis, we can see that our L changes from L1 to L2. So what we have here, from here to here, is delta L, meaning change in L. And on the vertical, it changes from T1 squared, T squared 1 to T squared 2. So this is represented here. So we have delta T squared. Okay. Great. Now, I need a paper to do this calculation. Yeah, I have a paper here with me. Now, to do this calculation, our slope S is the change along the vertical axis divided by the change along the horizontal axis. You see? And this is equal to T squared 2 minus T squared 1, you see, divided by L2 minus L1. You see, T squared has changed from T1 to T2, L has changed from L1 to L2. Okay, great. Wow. Okay, now we have to take the difference, the second one minus the first one. This one to the second one minus the first one. Okay, let's bring this and see. We use our scale to take that. Okay, this is 5. And how many divisions do you have after this 5? 1, 2. I remember we say every division, look at here, every small division on the vertical is 0.05 and two of them make 0.1. So if this is 5.00, okay, and you have 1, 2, this 2 will be 0.1. You add it to 5, this should be 5.10. So your T2 is 5.10. Let me open bracket. and then minus t squared 1. Okay, t squared 1, look at it here. This is 0.50, then two divisions will be 0.6, two more divisions will be 0.7. So you see 0.5 here, 0.6, 0.70. So this is 0.70, close bracket. Then you write the unit on the vertical axis. The unit is second square, so we have second square divided by L2 minus L1. Our L2, remember, okay, this one, we use the scale on the horizontal axis. From here to here is 20. We have 10 divisions, so 20 divided by 10, each one will be 2 units. So this one, this is where we have 120. So the next small one will be 122, and the next one will be 124. So our L2 is 124 minus L1. See? Okay, every division is 2, so every small division here is 2. So this should be 2, 4, 6, 8, 10, 12, 14, 16, 18. So I have 18 minus 18. This is 0.0, this is 0.0, and the unit here is centimeter. So let's bring our calculator and see. We'll press 5.10 minus 0.70, and this will be 4.4. So on the numerator we have 4.40 divided by, in the denominator we have 124 divided by 124, sorry, not divided by, 124 minus 18, and this will be 106. Now we combine this unit. This is second squared per centimeter. Next, we divide the numerator by the denominator. 4.4 divided by 106, and this will give us 0.0415, correct to 3 significant figures in second squared per centimeter. Now this is our slope. Okay, this is our slope. Now that we have calculated the slope, let us look at the next problem. It says calculate the area E in slope S. How do we get the area in the slope? Okay, we have a formula that we use to get the approximate value of the area in slope. I'm going to show you the formula. The formula says area in slope equals 4W divided by NR. 4W divided by NR. This is the formula for calculating the area in slope. This W is called vertical scatter. Vertical scatter. Now let me show you that on the graph here. This is the graph we plotted. Okay, let me zoom. Okay, great. Now this is the graph we plotted. Our points are here: 1, 2, 3, 4, 5. Now we look for the point that is the farthest from our line of best fit. This line that we have drawn is called line of best fit. So you look for the point that is not on the line and it is the farthest away from the line. As we can see that all our 3 points, we cannot say that the line passes through all of them. but the distance is so very small. If you look at this one, if you look at this one, for example, you see that it doesn't pass exactly, the line doesn't pass at this point, okay, but it's very close. If you look at this one, it's also like that. If you look at this one, it passes through that point. If you look at this one, is also very, very close. If you look at this one, it passes through that point. So here we can only have approximate value here for the W. If, for example, we have a point such as this one, you can see this one is not is not one of our point. Of course, I'm just using it as an example. Now, you can see that it is far from our line of best fit. So we take the distance from here to here, where the point is, to our line here, and we measure that on the vertical axis. We go to the vertical axis and take the difference, and that is our W. If we have other point, let's say you have a point here, we have a point here, we have a point here, that our line doesn't pass through them. So we look for which one, we look for the one that is farthest from our line. And again, you can see that it's still this one. This is close to the line. This is further away from the line compared to this. This one also compared to this is further away from our line. But this is the farthest, okay? This is the farthest from the line. And remember, we are taking it vertically, not horizontally. Okay, vertically, this is the farthest from the line. But our points are very close to the line, so we can only get approximate value of the W, and we are going to take half a division on the vertical axis here. We know that each small division for the primary degree is 0.05, so we'll divide this one by 2 and take it as our W, because our W is so very small. As you can see, this one, see, is so very small. The distance between this and this is so very small, so we can just approximate that by dividing the minimum division by 2. Okay, if we do that, we can see this is 0.025. It will give us 0.025. Then what is n? N is the number of observations, okay? Number of observations, okay? From your graph, how many points do you have? You have 1, 2, 3, 4, 5, and you can also get that from the table of values. Can you see 1, 2, 3, 4, 5? So your n is 5. Your n is 5. R is the horizontal range. We call this horizontal range. Horizontal range. Horizontal range is the difference between the highest value and the lowest value on the horizontal axis. On the horizontal axis, what you have is L. Now, according to the point here, the minimum value is where the minimum value of your L is at this point, where you have the minimum point here, and then the maximum value is this. Okay, you go down and take it. Alternatively, you can just use your table of values. You see, from the table of values, this is the highest value of L, this is the lowest value of L. So you take the difference between the two. So your L, your R should now be 100 minus 30, and this should give you 70. So this is my R is 70, but should be in centimeter. Even this one, since it is vertical, and what we have on the vertical axis for the vertical scatter, we did not write the unit t square second square, so this should be second square. Now from here, if we substitute these values, we will see that our E, the error in slope, let me zoom that, the error in slope will now be 4 times W, and W is 0.025. Okay, everything in second square. Now divided by n. Our n is 5 because we have 5 observations. Multiplied by 70, and then everything in centimeter. Okay, so this is equal to, let me bring 4 times 0.025, and this will give me 0.1. Okay, 0.1, then divided by 5 times 70, this will give me 350. Then I will combine the units, so I have second squared per centimeters. So when we divide 0.1 by 350, this is what we will get. It means we have we can see that this is -4, so we have 4 zeros. Okay, 0.000, then followed by the first digit. We'll approximate this to 3, so we have 3 here, then in second squared per centimeter. So this is our error in slope, correct to one significant figure. Now going back to the manual, the next 2 questions, I will leave them to you. State any 2 precautions you have taken to ensure precise result. Then why is a spherical bulb preferred to bulbs of other shapes for use in this experiment? These are questions for you to answer. Then we go to the conclusion. Now, the conclusion is related to the aim. The conclusion is related to the aim, the purpose of the practical. What are you doing this practical for? What is the aim? The aim of the practical is to determine the acceleration. Where is the aim? The aim here, to determine acceleration due to gravity, meaning to get g. So it means before you conclude here, you have to calculate g, and then you give your conclusion. Okay, how do you calculate g? You have already calculated the slope, right? Now go to the theory. The theory will tell you what to do to get g. You see, they say hence g can be calculated from this equation. You see, g equals, this is the formula that relates the slope s and the g. Now if you interchange them, you get g equals 4 pi squared upon s, where s is your slope. Here you calculated your slope. Can you see s? You calculated that and you got this 0.0415 in second squared per centimeter. Okay, now this formula is telling you that to get your g, you just have to say g equals 4 pi squared upon s. So we are going to do that now. Okay, now let's do the calculation. The formula says g equals 4 pi squared upon the slope s. Okay, and we got the slope as so let's do the substitution, and this is equal to 4 pi squared divided by our slope is 0.0415. in seconds squared per centimeter, and this is equal to, so now let's do the calculation. 4 pi squared divided by 0.0415. Okay, so we got 951.287 approximately. Now we have to change the unit since it's denominator, so this becomes centimeter per second square. So this is our G in centimeters per second square according to our observations. Now if I need my G in meter per second square, because this one is in centimeters per second, I will now divide it by 100 to change the centimeter to meter. So this will give me 9.5, approximately 9.5 in meters per second square, 9.5 according to my observation. So G should be a minimum of 9.8, but now I got 9.5. So this means there is some error. I'm going to calculate my percentage error in G. Okay, G is approximately 9.8 meters per second. But now I got this. So what is the error in calculating my G? So percentage error in calculating my G, in determining my G, is equal to the error itself divided by correct value. Okay, and then I will multiply this by 100. Okay, now this is equal to get the error, I will take the difference between the two. So this will be 9.8 minus 9.5. Okay, and the correct value is my 9.8. The unit will cancel. I have meter per second square here, I have meter per second square here, so the two will cancel, so I don't need them. Now 9.8 minus 9.5, this will give me 0.3. Okay, now divided by 9.8, and then I have to multiply this by 100. So let's do that using our calculator. So 0.3 divided by 9.8. Okay, if I multiply this by 100, then my percentage error is approximately 3.1%. Okay, this is the percentage error in calculating my my G, in determining my G. Then percentage accuracy, I want to know how accurate I am in determining this G. This should just be 100 minus 3.1. Okay, 100 minus 3.1. So I am 96.9% accurate. Okay, in this experiment, in this practical, I am 96.9% accurate in determining G. Okay, so in the conclusion, you will say, in your conclusion, after calculating your G, you conclude by saying, therefore, the G, or the acceleration due to gravity, is approximately, then you put the value you got 9.8. So 9.5 meters per second square. That is your conclusion. But you can see we cannot conclude without obtaining the value of G, because our purpose is to determine that G. I think this is the end for practical number 5. Okay, there is one thing I didn't mention. When you are plotting the graph, you can see that you have title here. So you say a graph of, then you mention the quantity on the vertical axis, and say against, then you mention the quantity on the horizontal axis. Like this one, the quantity on the vertical axis is t square second square. So here I will say a graph of t square open bracket second square close bracket against, then I mention the quantity on the horizontal axis. On the horizontal axis I have L, so I say L in centimeter. With that I have given the title. Then you write the date here. Okay, we already explained the scale. So with this, I thank you all for watching. We shall meet inshallah in the next video for chapter 6, determination of the height of a rate of stand. Thank you for watching. Assalamu alaikum.